Welcome to week 4, and this week is long-range pollution transport. Anything that gets emitted into the atmosphere, whether it's natural or man-made, gets transported, and it can go surprisingly long distances. So this week we'll be looking, for example, at the transport of volcanic ash, the emissions from forest fires and dust storms.
We have to be aware and want to understand how the different gases in the atmosphere can have very different sources, how they can interact and react in somewhere else, and that consequence can come back over our heads and be very important in our own lives.
So something can happen somewhere else, nothing to do with us at all, and then it arrives.
Absolutely, absolutely. I mean, the ozone depletion story was a good example. So creating CFCs, chlorofluorocarbons, putting very small amounts into the atmosphere, tiny amounts, transporting it all the way to the poles where you have an incredibly different atmosphere, different clouds, different chemistry. Suddenly you create something that destroys ozone much faster than actually anyone had ever imagined at the time. It was a real discovery from observations.
There are such strong patterns. Even this one diagram shows things from ships, emissions from wetlands, lots of different pollutants, and there's such, it's here and not here. But then they do get mixed in, they travel around.
Well, they are transported and transformed, and so pollution from Asia goes to North America, West Coast. Pollution from Europe goes into the Arctic, and we can see smog in Spitsbergen, similar to that in London nowadays when the events, so things going up from here. Russia also is a large industry which the wind systems takes it into the Arctic, so pristine regions, and when we have no ice here we're going to get a lot more shipping because it's cheaper to go from Europe to Asia via this route. Although in this projection it doesn't look like that, but it is actually quicker than going through the Red Sea. So we're very concerned about pristine regions being impacted by shipping, and here you can see shipping emissions which we're observing from space. That's actually oxides of nitrogen again. And
this really highlights the reason why you need both chemistry and weather models together. It's not good enough to understand the chemistry without the weather.
Well, basically, it's such in the stratosphere or in the troposphere is that the dynamics are creating the air mass chemical vessel. The conditions for the chemistry, which are temperature and pressure, are being controlled in large part, and any surface for heterogeneous reactions is being controlled by the dynamics. And if you change the dynamics, you'll change the chemistry. The chemistry long term can impact on the dynamics by changing surface temperature, for example, and changing as a result of that flows in the atmosphere and around the atmosphere. So this is why we need to measure both the meteorology and the chemical composition.